A quick explanation of how VTEC works. VTEC by Honda or Acura make engines more powerful and more efficient at the same time. This is a cylinder where air and fuel is combusted then exhausted. As the piston moves up and down, it sucks air in through the intake port, then pushes it out once combusted with fuel through the exhaust port. There are valves opening and closing these ports. A spinning camshaft controls the action and timing of the valves. Along the camshaft there are lobes which come into contact with either rocker arms, push rods or hydraulic lifters depending on the engine. Smaller cam lobes limit the amount of air intake and is better for fuel efficiency and low speeds. Bigger cam lobes open the intakes further, earlier, and close them later, allowing more air into the combustion chamber, and more oxygen means more power. But this is inefficient at low revs and bad for fuel economy. Honda used dual overhead cams and VTEC uses two cam lobe profiles to use small lobes at low revs and larger lobes at higher revs. The larger lobe sits between the smaller lobe. Rocker arms are the middlemen between the intake valves and the camshaft lobes. At low revs, the smaller rocker arms are the only ones moving the valves, limiting the air intake. The bigger lobe's rocker arms are not connected and do not impact the valve opening. When the ECU detects a speed and RPM above a certain threshold, it sends a signal to a solenoid control valve that pushes a hydraulic pin through the rocker arms, connecting the larger lobe's rocker arm with the smaller ones. Now the larger lobe can push the rocker arm, allowing more air to come into the combustion chamber and improving power. And when you let off the gas, the hydraulic pins retract, disconnecting the larger lobe and rocker arm, leaving the smaller ones to control the valve for improved fuel efficiency.